Okay, today we're going to be talking about slope. We'll talk about a couple of the vocab terms that deal with slope, especially a secant line. I kind of hinted at that yesterday. I kind of showed you what I was talking about. But the goal today is to really nail down what parallel and perpendicular is. You guys had a really good understanding of it yesterday. It's to go through at least a couple examples of this so you can see different styles of problems that you have. And then that's it today. That's kind of what I want to get to. The things you do in class today we'll cover as your homework, so you won't actually have a book assignment today. So it's kind of nice. Next Monday, Tuesday, we're going to do a review, so you'll have a practice in your hand on Monday. And then Wednesday will be our test next week over chapter 1. After that, when we move into chapter 2 stuff, then we continue with graphing, but very, very different types of materials. So we'll kind of look at that next week. Next Friday, I warned you of this. Next Friday is the last day I'll accept any late work, missing assignments, zeros, fixes, all that good stuff. Except for your test retake, that you have like 1 week from next Wednesday. So I'll try to give you your scores back to you on Thursday. That way you can kind of see, okay, I definitely need to retake it or not. Remember, you always have to do the 10 minutes with me before after school, and then we can figure out a time that you want to retake. But it's got to be done within 1 week of that. So it's got to be done before the end of the quarter. The end of the quarter is 2 weeks from today. So not next Friday, but the next Friday after that. So I'll send an email today. It'll actually come out probably tonight. That just kind of remind you that when the last day that I'll accept homework and when your test is and all that. And I think your parents will probably receive the same email just to kind of let you know. All right. For me, let's go through a couple things here. Let's think about just what in general slope. Okay. Yesterday I did a very similar problem to this where you have lines like this. These are curves. They would have changing slope as you go. Slope is when you pick 2 points and you draw a line. Like for instance, if I were to pick 2 points over here and find what they call the average slope. Average slope between 2 lines is that coordinate that you do, and you do this traditional formula for average where you go y minus y over x minus x, right? We do that. This line, if you see it, it did actually intersect this curve. You can actually see the curve poked out a little bit. It actually intersected, bless you, it actually intersected the curve twice. That's called a secant line. When you look at that line, what type of slope is it? Positive, negative, zero, or undefined slope? Negative. Negative, it's going down to the right. Okay, so that's a negative slope. So whatever this number is, we know it's going to be negative. You know that. I don't care where the negative sign is on the 2 numbers, be top, bottom, middle. It's negative slope, you can see it. Well, the slope actually changes because if I were to pick a different point down the road, let's say I were to pick, I picked these 2 points, slope changed. Now it's positive. Because it's constantly changing over the graph here. Eventually you'd hit 0 slopes and you hit peaks and valleys like mins and maxes. That's the reason why we would actually do the differential quotient, something that we did earlier. Earlier in this chapter, this is the formula that we did for the differential quotient. These probably took the most time for everybody. Everyone remembers that when we did that, when we're plugging in functions. It takes forever to do a differential quotient, especially if they're really, really big problems. I think I only said a few kind of quasi-big ones where they had squares in them. But this formula is actually how you find these peaks and valleys. A lot of people don't know that. It's something that you'll eventually learn in Calc 1. And the other reason why we do that, we do this differential quotient. It helps us find the peaks and valleys because we know the slope there is 0, because it'll be a level line. Because as you see, it's actually changing from positive to negative. Well, at that exact moment when it makes 0, that's called the relative max or min. Okay, it could be max or min because this would change from positive to negative. So it's an inflection point. And that's what we do differential quotients for. So you're starting to see like all the pieces, like individual pieces. We just haven't put it all together yet. So there's lots of stuff that we do here. But the average slope is kind of a key thing because this thing mimics an average slope. It doesn't look like it, but it's taking off. This is just f of some number. So this is a y number. This is a y number. You're subtracting them. And then you're actually subtracting the 2 x's, which are these. This is what you're subtracting on the bottom. This is the first x. This is the second x, and eventually the x's cancel, so you're left with h, because those go away. So it is actually doing the normal average slope formula. But for us, how we're going to use it today is we're talking about not only just secant lines, but we're talking about parallel and perpendicular. Because if we can make lines parallel, we can eventually approximate what slope is. So what I mean by that is, in calc, when you're looking at the same curve, you got this curve going on, I don't care where it's going, blah, 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 there it is. Okay, you got some curve going. And you want to find slope of the line at one specific spot, called an instantaneous slope at a certain location. So like maybe right here. I want to find the slope right at this moment. That line, the slope at an exact moment would actually be called a tangent line. It's that line that we talked about in geometry class. I'm not talking about sine, cosine, tangent. I'm not talking about that. But a tangent line, like on a circle, is a line that only grazes the circle at exactly one location. And I wish they would have picked a different word other than tangent. But the idea is that we can approximate that slope at that exact moment by just picking points that are really close together. And that's kind of what we've been doing. We've been picking points like this, drawing a line that connects them, and hopefully the lines are parallel, because we talked about yesterday, if you have a parallel line, then you have the same slope. So if you could pick points that mimic like a parallel line to the tangent line, boom, you have your slope at that exact moment. So it's a secant line, right? So that's kind of the concept. That's the whole goal of like what we're trying to learn, but we're doing it piece by piece. Eventually in calc, we just kind of fit all the chunks together and hopefully you can remember what we did. But yeah, same slope's got to be on the same plane, so it's got to be coplanar. And they do not intersect. Do not intersect. So those are like the key three things we talked about yesterday. And again, if you think back to geometry days, we talked about Euclidean and non-Euclidean geometry. Euclidean is on like a flat surface. Non-Euclidean is 3-space. We're not going to 3-space. We're going to 2-dimensional like this, flat surfaces. So that way parallel lines actually exist if you do the limits. All right, questions on kind of the overview. I know that was like the broadest way I can explain why we're doing this. Okay, now let's do an example here. So yesterday we did one where they give you like a couple points on the actual on this actual graph. So I'll just ask for a couple points from you guys. So give me just one coordinate.
4, 3.
4, 3. Okay. So 4, 3. This will be point A. I need one more.
12, 4.
12, 4. You can say 12. That was weird. All right. So 4, 3. 4, 3, and 12, 4. 12, 4. Okay. Now, what kind of slope is that? Positive. I'm very exaggerating that line at the top of the dot and bottom of the dot to exaggerate that it's going, because it almost looks like it's horizontal, but it's not. You could count with your fingers, figure out slope, but if I want to be parallel to this thing, I have to have the same slope to it. But I just need a different point to go through. I don't want to go through 4, 3, I don't want to go through 12, 4, or anything that appears to be, on that line if I were to extend it. But I just need another dot that is clearly not on it.
0, 0.
0, 0, good choice. That's what I would recommend. So 0, 0. If I want to make a parallel line to this thing, all I need to make sure of is that I know the slope and I know my starting point. Well, if I want to pass through, a point like 0, 0, just use the same slope. So what I'm going to do is, let's go find slope here. So slope, if I subtract the y numbers, which numbers are my y numbers here?
3 and 4.
Yeah, 3 and the 4, the back numbers. We're going to subtract these, so 4 minus 3 or 3 minus 4, I don't care which order you put it in. Looks like I'm going bottom up. So 4 minus the 3. So now I have to go 12 minus 4. So this turns out to be 1, that turns out to be 8. And so there's your slope. It's 1 over 8. So rise 1, run 8. And so doing that, if I rise 1, run 8, 1, 2, 3, 4, 5, 6, 7, 8, there's your line. There's your line. And they should be parallel other than that horrible artistic talent. That's how we make parallel lines. Same slope, exactly balanced. They're equally spaced. I know we talked about that a little bit. They're equally spaced down the road, so you kind of figure out the spacing there. the distance. All right, questions with how to find a parallel line, how to like draw it. Now notice when I did the slope, I just used rise over run, just think about common sense. Now, if I wanted to write this as an equation, like write the equation for the line that's passing through 0, 0, that's parallel to 4, 3, 12, 4. If I want to go to the equations, that's what you just did in your homework. So I'd probably go to point slope form. So y minus the 0 is the y number, this is your x number. My slope is 1 over 8, x minus the x number. This guarantees that I'm passing through 0, 0, and then I have a slope 1 over 8. Okay, questions, comments, concerns about any problems we've done so far? Perfect, okay. So we did parallel, that's pretty straightforward. How you can find parallel lines, you know, like county surveyors, when they're, you know, if you've ever seen them in town, they always have that tool where they set up in town, they're trying to figure out levels, and they're trying to point at certain directions. They're one of their main jobs when they're setting up a road for a county surveyor is to actually make sure that the lines are actually parallel to each other, so they'll set stakes out, and they can actually use geometry to make sure that the lines are equally spaced. So they can look straight down the road and look straight down the road on the other side that's exactly perpendicular to it, to make sure that the spacing is the same between the rows, unless it's, you know, eventually narrowing down from like 2 lane to a 1 lane. But that's like one of the main things, that they have to be equally spaced. The lines shouldn't be waving all over the place. Around here we have pretty good lines and pretty good road systems, but there's some states that if you pass through, they're really bad. I don't know who's setting those things up or who's doing it, but yeah. Well, let's move to perpendicular here. Okay, perpendicular, we'll go through some different points here. So now we're going to be perpendicular to something. So I need 2 more coordinates again.
7,
7,
7.
7? So we said. Another one, please.
-8, -12.
-8, -12. -8, -12. Okay, so 7, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7, 7, and -8 and -12 all the way down the road. Okay. All right. So we got our points. All right. We graphed it. Doesn't look so great, but we'll go with it. I need another point now, but that is not on that. Now I don't trust if 0, 0 is on it or not. I don't think it is, but
-4, 0.
-4, 0. Okay, thank you. That works. So -4, 0. So we'll call this point E. So E is -4, 0. So it's definitely on the line, because there's a little bit of a bow. I don't know how close to 0, 0 gets, right? Okay. Artistic talent's terrible. Okay, I don't want to be parallel anymore. If I had to be parallel, you would go through the normal setups where you'd find your slope. I'll go top minus bottom, so 7 minus the -12, the 7 minus the -8, and I'm going to get really nasty numbers. What is that? 19 over 15? Yikes. Ugly. Okay, anyway. Thanks for that. All right, so we have our coordinates, and now what we're going to do is we're going to find what we call a perpendicular line. So perpendiculars are how you find height of an object. That's what we use it for. So if you're going to find the height of an object, this is actually how your iPhone basically works when it can measure, because now the new iPhone cameras can now measure like distance between objects. It's setting up perpendiculars. It's, you know, wherever your camera's tilted, okay, your camera's, you know, is pointed at the object, you know, on the ground, and then you can turn the camera and point up in the air at the other object, and all it's doing is it's using the accelerometer in the phone to figure out what tilt you made. So it's basically figuring out, okay, this angle here that I just tilted was, you know, 20-degree tilt. So what it will do is it will self-adjust for 20 degrees. It'll make it perpendicular. It'll take this and turn it so it's a perfect right triangle, and then it can figure out the height that you're trying to find. Because it knows, for some reason, it has depth sensing. It can tell how far an object is away. That's how the iPhone like unlock system works, and I think Samsung has the same thing. That it knows the depth to the object itself, because one of the reasons is that it looks at how big the object is on the camera itself. So like if you had a dollar bill, those are like pre-programmed into like distances. So it knows a dollar bill is supposed to be 8 inches. Well, it's scaled it up, you know, if it on the camera, if it appears to be 2 inches, it knows that's how far away that object is. So that's not true depth sensing, that's kind of faking it. It just knows the proportion that it used to scale it down. But the iPhone like X's actually have true depth sensing. It knows that you're 2 feet away from the camera. So it's pretty accurate that way. Well, that's how it's doing it. It's doing a perpendicular line and then setting up the right triangle and actually doing the trick, which it's really fast at. It's insanely fast. It's not crazy accurate because it could be off. Maybe it didn't recognize the object correctly. But it can give you a really good estimate. So if you're like measuring, like, okay, is this about right? And you check the phone, yeah, it's about 3.5 inches. So I'm probably right on that measurement. It's quick for just if you need to eyeball something, get close. You can overestimate. But anyway, to do a perpendicular line, we talked about this yesterday. For perpendicular, you have to use an opposite reciprocal for slope. Opposite reciprocal. Now, I know that in geometry class, we talked about the word reciprocal was a property. It's an actual field property of a real number. That reciprocal is when anytime you multiply or divide numbers to make 1, right? That's the property for reciprocal. What we're gonna use reciprocal for in this case is just taking the fraction and flipping it over. That's the second definition for reciprocal. We're not talking about the property itself. So we are gonna flip my slope over. Now, what does opposite mean? Change the sign. It's the opposite sign. A lot of people have those two words mixed around. They think opposite means you flip the fraction over. That's what the reciprocal means. So in our case, to find this opposite reciprocal, you're going to flip this over. So my slope is going to be -15 over 19, and I would have to go graph where that thing is going. Now, since I have a starting point, I know my rise and my run. So I'm gonna drop 15, that's way down here, and then run 19, 12, that's 16, 17, 18, 19, so it's like way over here, and so there you go. That's the concept, right? So here's your right angle. You can set up your triangle, and now you could figure out the distance to the object, because you actually can find this point of intersection right here. That is something we will eventually do in chapter 6, chapter 7, I think as well. And so once we have that point of intersection, now you have a right triangle, because now we can find distances between objects. I have the formula up here, bless you. I had the distance formula up here at one point to find distance between any two coordinates. We'll eventually do that again. That's one of the things we'll talk about in like chapter 6 and 7. We're way past trig functions and all that good stuff to make sure that we can make like how to use this thing to its full potential. Because a perpendicular line is the perfect height of an object. It is the perfect height of how tall something is. We don't measure height by doing a diagonal line. Otherwise, everyone would be 10, 12 feet tall. Okay, questions on the concept of what perpendicular is? Okay, so I thought this was just kind of important. We needed to talk about this, and it was just something that I want you to know. Is there any questions at all? Okay, Monday we'll practice this a little more, a couple times. I'll have you do maybe like when you walk in, we'll maybe do like an entrance ticket like on Monday. But I'm not going to sign homework on this stuff because you just did 12 problems on graphing, and I don't think I need to sign more, do I? No. Okay. All right, we're done for the day.
Really? Yeah. I'm sorry.
Hey, do you guys want to hear
I was in your booth, but I still want to switch around. Yeah.
I want to make sure I did it right. So I should know. We're only supposed to do the first roll, right?
Wait, what is it?
That's what I did today.
Wait, no.
After
I'm
PT,
so proud of you.
so I was at Athletic.
This is different
And I was
shape.
starting on the end of like,
No. These ones. Oh, I yeah, I know what that. Don't ask me.
So what'd you do?
Because
Wait,
that
how can
my
obviously.
company,
how can you compare?
and it was
No,
like
the
8,
first one's
17,
the
and
sheet.
it was in the middle of an inch.
Like 282 more. That's not right.
31 points.
Okay.
Okay,
We'll get that.
what'd you get for number 3?
Like 4.94.
No, what'd you get for number 4?
Like 4.94 and then 6.36 for number 3.
Yeah, those are wrong.
They're both wrong.
Unless we had their wrong. That's no possibility.
I know.
What I do, like, get my mom to call school so I could have some of her filter and get it started. No.
Yeah, because you turned.
I can do it.
But I have to get someone else